I want now to talk about how we baseline our network. And I guess what the question there is, what do we mean by that? Well, it's pretty simple, really. Do you know your network? Do you know what's in it? Do you know what it constitutes, how it all fits together? And how do you go about filling in the gaps in your knowledge? Okay, so that's really what this segment's all about. And of course, we'll have a bit of demo in just to see how IP Fabric can help you fill those gaps. The key thing, I guess, to understand is that in any network these days, it's not just a network, it's a network of networks. It's that complexity of having lots of different pieces of network that we all have to operate in order to deliver a service, right? It's fairly straightforward. We all have wireless networks connected to campus networks, connected to WANs, connected to DCs, connected to cloud, and so on. So we often have the problem where we need to understand all of those different networks and their interactions between them in order to understand, is availability good for my applications? How is my network actually going to deliver this? And that doesn't just mean understanding different vendors. It also means that we have to think about, well, there's different teams involved potentially and different subject matter experts. So we need to be sure that we've got that central sort of coordinated view, I guess, of what's going on, so that we can avoid this problem of silos, the dreaded silos that everyone talks about. And of course, the way to do that traditionally would have been documentation, would have been to have made sure that all our documentation was up to date, that everything was of good quality, that it was consistent. Yeah, I don't think I've ever seen an environment where that's completely so from one end to the other, and I'm sure you are the same. So what we're trying to do here is provide this aggregated view to make sure that you're able to have that point of reference, if you like, of what the network actually looks like. And I was going to use a different term there, but my marketing buzzer went off in the back of my head, so I shan't do. But, so you've seen this slide already. This is IP Fabric's approach to that, and really what it's doing is something like this. You're retrieving lumps of config that might look vaguely similar, but might look different depending on which vendors you're doing. Here we've got obviously Cisco, Aruba, Arista. Anyway, if you can read one, you can read them all. But the point is that there are going to be other syntaxes in other different vendors that you can't necessarily read as easily. So what we do is we'll take all of those in and we put them into that agnostic model, so it can be queried in a way that makes sense to the people who's trying to consume it. In this case, it might be a table of data, as we've already seen on the product screens, where the data says the same things in the same way. But it also, and you'll notice this, it's not just taking that configuration data, it's taking state data with it as well, just to show what state those interfaces are in, for example. And of course, if you want to access that over API, you can get the JSON output that says the same thing, but then you can take on and use elsewhere. And that's the whole point of IP Fabric really is about us making that data available to whoever wants to consume it as easily as possible. It's there in your face. You can't miss it when you're logged into the UI. You don't have to go searching for it. You don't have to go building queries and whatever, because the data is already there and visible. And from an API perspective, we have this really clean REST API that you can extract all of the data in a very simple way. So you might want to ask things like, and you'll see these headings will look familiar from the assurance slides. You might want to ask things about the inventory and the config, like, where are my SFPs? Where are my APs connected to my switches? Are my switches configured with the same VLANs on their switch uplinks as the switches they're connected to? These sorts of things. So it's all about being able to ask those kinds of questions, and then we develop those further to be able to understand, well, look at the operational state and say, well, where do I have spare port capacity? Or is BGP doing the thing I expect it to in my WAN so that I can fail over if I have an issue? And then we'd feed that back into that end-to-end forwarding and say, well, okay, what path do users use in a particular location to take to get to the application they want? Is there a firewall in that path? Does firewall policy allow me to get to that application? So on. So it's all about that behavior and understanding the behavior. And of course, we've talked already about the snapshots. There's that point in time view. So all of those things we can say, well, what changed? What was good then and is different now? Anyway, what we're going to do is we're going to dig into a bit of a demo scenario. So we've got these, you vaguely recognize this from the diagram you've already seen. We've got an MPLS network in here connecting 4 office spaces, and with each with a different characteristic. One has a head office, campus and server room where the environment's been built by a VAR and documented really well and very cleanly. One's a colo space that's, to be honest, getting old and shabby, and people want to just want to move out of there, and so it's a bit haphazard. There's a very small sales office where it's just a couple of switches, and there's a new production facility that's, let's say new, it's been acquired from another organization. So there's a whole bunch of configuration that's different to everything else in the network. And what we want to do is be able to understand all of that. And we've got some projects coming up that we want to deal with as well. Things like configuration templating, things like an SD-WAN rollout in order to get more agile. A cloud migration activity is on the cards as well. So we'll look at how IP Fabric can support us in all of those projects. And of course, then network automation going forward. So I'm going to cut back to the demo for me. So you can see here, this is our baseline snapshot that's been created here. And what IP Fabric has done as it's gathered its data is basically allocated devices into sites. This is a sort of fairly simple construct in IP Fabric, but fundamental one. We do that in a number of ways. You can bring data in from external systems and use that to allocate devices based on what you've got in ServiceNow or Netbox or whatever other source of truth you might use. And then once it's there, if IP Fabric discovers other devices that are connected to that within the same routing domain, then typically what it will do is just drop those into the same sites alongside the devices they're connected to. You can also use the host name. If you've got good naming standards, you can extract the site location details from there, or you can even use the routing protocols and AS numbers and the such like if you should so choose. But we're finding more and more customers already have a source of that data externally. So we're seeing that more often being used to do that allocation. The other thing you'll notice here as well, while I'm here, is and Tyler, we talked briefly about the fact that we capture full snapshots, but we can capture ad hoc snapshots as well. So if you've only got a few devices that you're interested in, or if you've got an end-to-end path view and you want to update it to the very latest view of the configuration, you can just refresh the snapshot or capture a completely new one based on just that scenario without capturing the whole network, if that's what you want to do. So these are all elements that are of use in that sort of operational state. But once we've done all the capture and we've done all the building into the model, and we head down into the technologies again, we can start to look at things like the configuration and so on, as we talked about before. Now, the easiest and one of the standard automation use cases for configuration is that of NTP. So we'll dig into this one very briefly. And you can see under the management there, we capture all of the management state, but NTP is always an interesting one. Here you can see we've got a bunch of devices. We understand how those devices are configured and whether they're reachable. So we do the check to see the operational state to compare it to the configured state. And you'll see again, the intent rules here is showing us that there's a bunch of stuff that's green, where it's the NTP source is what we want it to be. And there's some stuff that's yellow, showing that the NTP sources are actually not what we want them to be and need changing. If I filter those out and just concentrate on the site, you can see that these are all in this new production site that hasn't yet been properly onboarded as part of the acquisition. So there's some work there that needs to be done to tidy that up. We can also do things like look at VLANs, where VLANs are configured and so on. So if I dig into the site summary here, you can see that in that new production environment, these are the VLANs that I've got, and they're configured across all of these devices. Just really sort of showing, I suppose, where those things are configured. I mean, this sort of stuff is gold dust, right? If trying to gather this sort of information together is often painful, but just to have it all to hand without having to go search for it yourself is super useful. We can then start to dig into the state, obviously, and again, spanning tree being something that has caused all of us problems at different times, I should imagine. We can look at spanning tree, but one of the things that we do is where we've got the ability to, we'll go a little bit further than just presenting data about the state and make some assumptions and make some really try and gain some insight from that data, right? So for example, we have this table here which talks about spanning tree inconsistencies, and what this allows us to do is actually dig into the spanning tree a little bit without you having to do it yourself, and just flag things up that may or may not be causing a problem. So in this case, it looks pretty good. I mean, there's no VLANs without spanning tree running. There are no ports with multiple neighbors. There's no issue with spanning tree mismatching with CDP. And certainly no issue with multiple spanning tree links between devices, but I skipped over one tab here because what we have here is a whole bunch of ports where the VLANs don't match at either end. And this is the beauty again of having the model. You couldn't log into one device and know the answer to this problem. You'd have to log into all of the devices at the other end and check back and see just where these mismatches are occurring. But because we have the data in the model, we just generate these reports for you.
Daren, this is John Herbert. Really
John.
Dumb UI question.
Yeah.
When you have the discrepancies, like in this case on the neighbor ports allowed VLAN mismatch,
yeah,
does that bubble back up to a high level report so I don't have to go to inconsistencies and then go through 5 tabs to figure out which one actually has a non-zero number? Do you see what I mean? It's like, is there a way without having to just look at everything to find out where the problems are?
Okay, yeah. So no, that's a really good question, actually. Thanks, John. The intent rules that we've shown at the top of of each of these tables are all actually gathered together on a dashboard, and I will show you the dashboard here. Which this dashboard gives you that indication at the top level of what issues have I found in the network based on all of the intent rules in the platform. The problem that you see here, of course, is that this is arranged in a default manner, right? You can tear these down, these dashboards down and build them exactly the way you want them to in order to get to the bottom of those sorts of issues very quickly. So you would, as you say, then come straight back to this and be able to see. And then from here, of course, you can click through to the individual devices. It's one thing that if you've got a particular device you want to look at, if you click through on one of these, it will just give you the full breakdown of exactly what's happening on that box. So I can do that thing of understanding how it's behaving across spanning tree, for example, how its switch ports are configured, so I can check to see what trunking issues I may or may not have. And if I've got it, IP Fabric will actually capture the configuration files, so I can look at the configs and actually examine them if I want to. I can go to that level.
So I've got a question for you, Daren. And in looking at the spanning tree analytics, especially as you're looking at all these different states, what happens if you're in a multi-vendor environment? And there's a document that Dell published that's very famous that rapid spanning tree in Dell is not the same as rapid spanning tree in Cisco, and they don't play well together or as expected. If I have Dell switches and I have Cisco switches in my environment, or if I'm in a merger, of a company, it was Dell and Cisco. How would I reconcile that kind of problem?
So we do track, for example, I'm just trying to think where it is. Yeah, so we do track the type of spanning tree that's running at a particular point in the network, for example. So interesting point about the Dell issue, because I'm sure my product folk will correct me if I get this wrong, but I'm pretty sure we track that through separately from everything else for that reason, that there are flavors of these things and not, and this. The PVST versus rapid PVST is a good example as well, where someone's configured something thinking it's one thing and it's something else. To be able to narrow those down and pin those down is really important. So we do gather as much of that as we possibly can and just present it out in this form. Does that answer your question?
Yeah, it does. I mean, I know it's not an easy problem to solve, but I was just thinking if I had those two inventoried, and they're both in rapid, and they both think they're in, designated forwarding, but one might not really be because of an inconsistency in vendor incompatibility. That's, that was more.
Point. Yeah, no, it's an interesting point actually, that there's certainly opportunity there for us to continue to look at some of these options and add those too. The point being that the data's in there in the model, right? We have that data, so it's really just how you present it out. So if it's, and this is again part of the beauty of what we're doing, if the specific view of the data that you're looking for isn't in the UI, then it's still generatable through the API, and if you should want to go down that path. But what we try and make sure is that you never have to do that if all you want is access to the data to view it.
Right, or more like, in the idea of this is our organizational standard. I remember the result of that document was multiple spanning tree was the most compatible between those two organizations. So again, recognizing that and flagging, say, hey, you have Dell and you have Cisco, you should be running multiple because of this was published by, that I think that would be another, if that's not something that you have now. No, that would be a great inconsistency to flag, to say you should be running multiple between these. So it's
an interesting point, because most of as you'll see, most of them are based on practical experience anyway. These kinds of inconsistency checks. We have, for example, MTU sites mismatch and those sorts of things, where we can just say instantly, right, okay, the links either end of these are not the same. Yeah. Therefore, if you try and run encapsulation over the top of these, something's going to break.
It's always MTU, right? Yeah.
Right. Of course, if it's not DNS.
Yeah, that's right.
But that's it. Yeah. So absolutely, it's all about that experience feeding into the UI on the platform. So
cool. Thank you.
I will make a note of that one. That's a really good question. Thank you.
To follow up on that, I think Arista also has one on MSG Domains. Sure. So as you're working through MSG Domains, Arista has some specific recommendations about what to do for that for defaults, because they do a different default for MSG domain configurations. It's different than like Cisco and everyone else. So you have to be sort of aware if you're creating additional ones in a similar way to the Dell one.
Yeah. Now that's, again, really, really interesting stuff, because it's, as we say, we gather the data, but this is that extra insight you need on top of that, right? And to make use of it. So and that's a good point. Thanks, Ed. Again, Arista, and the other thing that I wanted to talk about, or one of them, was first up resolution protocol. So as we mentioned before, so one of the things we do here is we not only just track the group states and how they're behaving, but again, this is that sort of indication of insight, I suppose. We'll do this. We'll check to make sure that the gateway, the first stop gateway, matches the spanning tree route, for example, if you're running them on the same switch, so that we're able to take those two things, bring them together, and just say, look, these are wrong. These need correcting, and there's an issue here. So again, it is about using that experience, using that understanding to take it to the next level. Was there anything else you wanted to ask about with the first hop resolution stuff?
Yeah, so can you identify like what the clusters are? So, if I have an A/B router, right, and A is supposed to be primary, B is supposed to be secondary, can I pair those up? Because it's hard to infer what the intended state is.
Yeah, so with the group members element here, what we can do is we can identify for each virtual IP which devices constitute the group for that IP. So that's tracked through here, complete with the group number and the devices that are, like I say, the devices that are involved in the priorities. We'll gather all of that data, so it's all here and available. But this table specifically is about tying a device to a virtual IP, so we know what those groups are. Yeah, awesome. And if there are issues, we can flag those up if you've got, as in this case here, if you've only got one device that's in the HSRP group, we'll flag that up. If there's 3 devices, we'll flag that up. And again, if there are 3 member routers, for example, we'll say, right, okay, actually something's gone a bit awry here. So again, it's just that thing of once you've got hold of a network, perhaps for the first time, and you really want to understand it and baseline it and get to the bottom of what's going on, you can look into how that's behaving. You may want to know what the routing table looks like across the whole of the environment, and this gives us an opportunity to dig into that and understand where those routes are coming from, what they where they're seen, so you can track through the whole network. Right, where are, if a change occurs and I want to know that this route is injected, is it going to make its way through to the opposite end of the network? Once you've got that full routing table, you can go through and understand that in detail. And again, you can dig into all of those different routing protocols and so on and so forth. What I did want to show you before we sort of moved on from this baseline aspect as well, I suppose, is the fact that once we've created that snapshot and things change between snapshots, we're able to see what that issue is. So in this case, coming back to the visualization, if we do an intent check, for example, and I do look at some of the built-ins, we can do things like this. We can see if there are single points of failure or non-redundant links in the network. And this will just flag up here. These 3 switches are single points of failure because you lose one and there's no alternative path for other devices and whatever that are connected to them. We can look at that and understand that. Now, as part of the snapshot process, what we can do is we can just literally switch snapshots and see how that changes from day to day. So in this case, I've just switched to day 2, and what you've now seen is that our single points of failure have gone away. Now, if I use the compare snapshots option here, I can show in more detail what exactly happened. So you can see here, this link was added in between this switch and this switch, and down here, these 2 links were also added in order to get us around that particular problem and to move us on. The beauty of the snapshot being that you've got that visibility straight away of the things that have changed and things that have moved. And just for completeness, we can also look at the custom checks that we talked about before, the intent checks, and overlay them onto here. And I can look at the configured NTP, and you'll notice now, well, if I look at the day 1 baseline, all of these devices that had NTP misconfigured have now been fixed in the day 2. So as things move and change, so IP Fabric snapshots move and change with the network.